Okay, this is example 1, and we want to solve the system by graphing. Okay, notice we're given a system right here of specifically of linear equations, right? These guys are lines, which you know how to graph already. And it says solve the system. Again, not solve the equation. We're not solving for one variable. We're solving for, well, we want to know what x and y is, so two variables. So let's maybe call this, you know, line 1, right? And maybe this guy, maybe in blue, we can call this line 2. So if we start with line 1, right, we want to graph this line. Okay, so how do you want to graph this line? So y equals negative x minus 1. Again, this is your preference. What I would do, me personally, is it's already in slope-intercept form. So it's kind of ready to go. I know that the slope in this case is the coefficient right in front of the variable, the mx. So my slope is negative 1, right? It's right here. This is my m. Now, when we talk about slope, right, we like the fractions. We want to write a rise over run. So this is really over 1. Let's see, maybe let's write out the y-intercept, right? Specifically the y-intercept, not the x-intercept. Well, the y-intercept is always 0, comma b. Excuse me. 0, comma b. mx, right, here is your b. And my b is, well, negative 1 in this case. So how you graph this guy is, let's go ahead and let me make this a little bit, let's see, bigger here. And I mean, we're going to graph both lines on the Cartesian plane, on both Cartesian planes. So pretend I'm using a ruler here, because you need to use a ruler, otherwise you will not find your point of intersection. So pretend I use my ID card, right, any straight edge. There's your y-axis, and there's your x-axis, right, really right there. Okay, so how do we graph this line? Well, we know from, again, from last class, well, with my husband, you guys talked about the slope-intercept form. So we plot, right, this point first. Okay, so let's zoom in here. Okay, so 0, negative 1. So 0, negative 1 is right here. Okay, and I actually want you to label it. Okay, because I need to know that you know where that point is. It's on the y-axis, not the x-axis, because some students want to write it here, right there, but that is not, that's negative 1, comma 0, and we want 0, negative 1. Remember, your b has to lie on the y-axis, hence it's called the y-intercept. So let's make this smaller. Okay, so now where do we go from there? Well, our slope is negative 1. So let's maybe put this in black. This is rise over run. So, well, rise is up or down. So I'm going to leave the negative in the numerator. You could put it in the denominator if you want. You can put it in the middle as well, but the middle doesn't really help you with navigating your next point. So we have, this is going to be, it's either down or up. So down 1, right? That's your rise going down. And your run is either right or left. So this is going to be to the right 1. So down 1 to the right 1. Whoops. I didn't want to cross that out. Okay, we'll just, so down 1 to the right 1. So I'm going to go down 1. So down 1 to the right 1. And right here's the next point. And I can keep doing this, right? I can go, this is a slope, down in red, down 1 to the right 1, down 1 to the right 1, right? It's just a staircase. And I really want this black, not red. And I'm going to erase this just because this is not me being picky, but you have to make sure not to make your points too large. I'm exaggerating, whoops, don't do this, because if you do this, when you graph your line, I mean, it's really hard to, if you go here, 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 and there are a lot of lines through that big point, so make sure to make your point, of regular size. I mean, maybe my 0, -1 is too big, but again, using a straight edge. So I'm going to try my best to graph this. Okay, that's pretty bad. Again, that's why we use a ruler. And, okay, so it's supposed to go through that point, that point. Again, yours is going to look a lot nicer than mine because you have a straight edge and I don't on this app. So this is line 1. This is Y. This line is actually, let me write it as, right up here, y equals -x minus 1. Okay, so let's graph the other line. And maybe, again, just to change colors, let's do this in blue. So our next line is, so line 2. Okay, 4x minus 3y equals 24. Again, your preference, how do you want to graph this line? It's not in slope-intercept form, so we can rewrite this in slope-intercept form. You can use the x-intercepts, or the x and y-intercepts. You can plot just, -2, -1, 0, 1, 2, a couple of points. Again, it's your preference. I'm just going to go ahead and use the slope-intercept form. So this is your, this is your AX, right, or AX plus BY equals C, or from above, I think, let's see, ABC, D, E, F, right, this is your D, E, and F, your DX plus EY equals F. Okay, so let's put it in slope-intercept form, that is solve for Y. So I'm going to subtract 4x from both sides. Right, and I want that, well, that's going to be 0. 24 minus 4x. Okay, so I want y equals, not -3y equals. So I'm going to use, right, what we did in chapter 6, the property of, multiplicative property of equality, which is multiplying by -1/3, which is really the same thing as dividing by -3, right? Why -3? Because I want this to be a 1. And if I don't divide it by negative, it's going to be -y. So we can do plus plus. Y equals, and then I get -8. And then negative divided by negative is positive. And I get 4/3 x. Okay, so what is my slope? What is my y-intercept? My, let's see, m equals, my slope is 4/3, right? It's the coefficient in front of the x. So 4/3, and, well, they're both positive. So rise over run. Rise, it's either up 4 or down 4. So this is definitely going to be up 4. You can do, and then to the right 3 or left 3. Okay, and the y-intercept, right? The point on the y-axis. Y-intercept is 0, b, and my b in this case is -8. Now, again, if you wanted to rewrite this as 4/3 x minus 8, that's fine, because then you can clearly see, mx plus b, but it doesn't matter as long as you understand that the slope is a coefficient in front of the x variable, then you're fine. Okay, so 0, -8, and our slope is 4/3. So we go back to our rectangular coordinate system. So 0, -8. And so 1, 2, 3, 4, 5, 6, 7, and, whoops, 8, right, 2, 3, 4, this is -4, right, 5, 6, 7, and then this is 8. And again, I'm going by ones. If you want to label your access, you know, by twos or five, excuse me, or 5, 10s, it depends on your problem. In this case, using units of 1 is fine. So there is our y-intercept. And then remember, our slope was 4/3. So I'm going up 4 to the right. Was it 4/3? I think it was 4/3, not 3/4. Let me make sure. Yes, it was 4/3. Okay, so from 8, I'm going up 4. So 1, 2, 3, right? Obviously 4 is there. And then to the right 3. So 1, 2, right? 3 blocks. And then there's our point, and I mean, you can see where it's going to intersect already. But if you want to keep going, right, up 4 to the right 3, right, there's your up 4 to the right 3, 1, 2, 3, and then here's your other point. And of course, if you graph this line, right, connect the dots with a straight edge, right? Notice when you don't use a straight edge, it's very hard to find the point. Here in this case, it worked out nicely. And if you wanted to maybe make that red, that's fine as well, or you can leave it black. So this is what we're looking for. This is the solution, right, to the system. Point of intersection. Well, what is the point of intersection? And it looks like 1, 2, 3, comma, and then down 4. So this is the solution to the system. And if you look at the diagram that I explained in the video prior to this, we have a solution. So actually, let me just write it here. Since we have a solution, right, our system is consistent, because that means you have at least one solution. Well, it's right there. There's our solution. And is this independent? Are these lines independent or dependent? Well, if we look again at the a diagram I kind of constructed, you will notice that they're independent, right? Because they intersect at one point. So the lines, you have to say the lines are independent. Okay, and this is important. You have to say the lines. A system, we say, is consistent, but when we talk about dependency and independency, we're referring to the lines, meaning we can't derive, right? This line, I can never derive it from this line. Well, first of all, they don't have the same slope, so they're not going to be the same line. Let's see, something else I wanted to say. Oh, I do want you to check the solution, right? That was the whole point of chapter 6, right? We were checking linear equations to prepare us for linear systems, or systems of linear equations. So to check your solution, well, what am I checking? Well, what was our point of intersection? Our point of intersection was 3, -4. And we're just gonna, right, plug it back into our two lines above and see if we get the same thing. So maybe we can do this. We can do this right here. So y equals -x minus 1. Well, what's our y? Our y is -4 equals, okay, and x is -3. Well, are these equal? Yes, they are. And similarly, 4x minus 3y equals 24. And again, substitute x and y. And does that give me 24? Well, x is 3, y is -4. And then, yes, obviously this works because 12 plus 12 is 24, right? Or 24 equals 24. This is important because this this proves that this really is the point of intersection. Okay, so that's the big picture of this section.